Okay, are we all here, folks? I know, bummer. Monday notes. So what's going to happen today is you're going to just be given a bunch of random pictures, and we're going to use these new relationships between angles to either solve for a missing angle measure, just name the different kind of relationship, just kind of a whole bunch of stuff. But at the beginning, it's just a bunch of new words. And it gets kind of confusing because it's all new to you. But we'll spend a few days on it, and it will become pretty much like a second language, all right? But the first relationship we have between angles are adjacent angles, and they share a common side and a vertex. So if you are highlighting, I'm going to highlight what that would look like, so I think that's helpful. So if I look here, examples 1 and 2, do you guys see how they have the same vertex and share that side? That's why they are adjacent. And same thing right here. They share that common side. They're next to each other. That's the way you can think of adjacent angles. If we look at these non-examples, this one's pretty straightforward. Why are those two angles not adjacent? They don't have the same vertex. They're not even next to each other, right? It's pretty obvious. Those would be not adjacent. Okay? Our next pair is called a linear pair. What word do you guys see in linear? Line. And how many is a pair? So two angles that make a straight line is a linear pair. So they form opposite rays is what's happening, so they make that straight line. So if you guys look here, that's our straight line. They're making a linear pair. If we look at our non-example over there, what's wrong with our picture?
Not straight.
Yeah, do you guys see how this is not a straight line right here? It's crooked. There's like a kink in it. You can't have that. That's not a straight line like that guy is. Okay, now vertical angles are formed when two lines intersect, kind of making an X. And they're always congruent. Will you guys maybe star that for me? That's really important. They are congruent, made of the same measure. And actually, when you have one pair of vertical angles, you usually have a second pair, right? So if I look here, angle 1 and angle 2, that's a pair of vertical angles. They would be the exact same measure. And same with angle 3 and 4, that's another pair. They're both two different pairs of vertical angles. Let's pretend angle 3 is 40 degrees. What other angle out of those 4 would be 40 degrees?
4.
Yes. That's perfect. Maybe write this down. It's a good example to reflect back on. And if I know that angle 3 is 40 degrees, what would angle 1 have to be?
140.
How'd you get 140?
Subtract that from 180.
Yeah. You guys see that? Because today you're going to do some solving and you're going to kind of struggle with, do they equal each other or do they add to 180? So this is a nice one to come back and look at. If we look at our non-example here, why aren't these two angles vertical?
The lines up straight.
Yeah, this isn't a straight line right here. Again, it's kinked. They have to be made by straight intersecting lines. Perfect. All right, let's try look at a diagram now and answer some questions, okay? Name an angle that is a linear pair with HKE. If I trace out HKE, I want another angle next to it that makes a straight line. Anyone have an idea? FK. This one? FKE? Is that what someone said?
No,
FKG would work too. Yeah, those actually both work. I'll write them both down. So FKE. That one works. FKG also works. Anyone see a third one?
HKJ.
FKG.
Yeah, HKG also works. I think we got it. There's only 3. And we got them. Very good. Name an angle that's adjacent to GKJ. GKJ. So we want to share a side with that red angle. Which angle we should share a side?
FK.
FKE. Close. That would share the same vertex. FKG. Yep, FKG would share that side. Someone else have a different one that you see?
HKG.
Yep, HKJ. I think there's only 2 on this one. Name an angle that's vertical to HKG. So remember, that's where you have 2 lines intersecting. They're kind of making an X. What would be vertical to that guy? Yeah, you got it. There's only one answer on that one. Perfect. When you're ready, you want to flip it over. Okay, now the next 2 kinds of angle relationships deal with their measures. 2 angles that add to 90 are called complementary. Complementary angles add to 90. So here's an adjacent example where they're next to each other. How do I know angles 1 and 2 add to 90 there?
The box.
You got it. And how would I know here if they're not adjacent?
Add the
Yeah, you could check, right? Does that add to 90? It does. Oh, it does. Yep. So what do you think supplementary angles would add to?
180.
They do. Yeah, they make a straight line. That's why every linear pair is supplementary. So you would automatically know on angles 3 and 4 are supplementary because they make that straight line right there. So they would add to 180. And then on our non-adjacent pair, you could just do the math, right? What's 120 plus 60? Yeah, it checks out. It checks out. Okay, so let's try a little bit of algebra with complementary and supplementary angles. Just find the measure of 2 supplementary angles if the difference in measures of the 2 angles is 18. What's a key word that you guys see? Difference, that's a good one. Any other words that you guys like that might help us? Supplementary. I think that's a good start. Supplementary angles add to what?
180.
I'm going to put that right here. So I know I have 2 angles that add to 180. I don't know what my 2 angles are. I'm just going to give them some fake names, angle A and angle B. And again, we don't really know what either of them are. And in math, if you don't know something, what do you typically give it? What do you call it? A variable x, sure. So I'm going to call angle A x. And then it says the difference between my 2 angles is 18. How would I write that? What's the difference mean?
Subtraction.
Subtraction, right? So I know that angle A is x, so x minus 18. Would that tell me the difference between those 2 angles is 18?
Yeah.
And then together, what do they add to?
180.
So that's our equation. X plus x minus 18 equals 180. Now we just simplify. Anyone get an answer for x? Me too. 99. So let's say angle A is 99. How do you find angle B?
180.
Sure, you can subtract from 180, or you can just plug in 99 right here, right? 99 minus 18 is what?
81.
81. Okay, why don't you guys get a head start on the next one? I'm just going to take a hot lap and then I'll hop on the board. But see if you can get a head start. Same kind of problem. You guys notice this one's complementary though? I hope. Are you kind of close to the same? You guys get 26 for x. And how do you find the measure of the other angle?
Plug it into that.
Plug it in, yep. Six, four. You guys know what perpendicular lines or what perpendicular means?
What?
Next to each other. See a lot of people going like this. What kind of angle do they make?
Cross.
Right, make a cross, right? But a specific kind of angle when they intersect.
90 degrees.
Yes, very good. So we're gonna write this down. Line, segments, and rays that form four right angles are perpendicular. Perpendicular lines intersect and create congruent adjacent angles because they're all right angles. And then symbolically, this upside down capital T means perpendicular. So if you were to see it like in your instructions, that's what that means. So if we wanted to write that line AD, all right, AD with a line on top is perpendicular to line CB. So let's see if we can do some solving with perpendicular lines. Find x and y, so line PR and SQ are perpendicular. What do you guys want to solve for first, x or y? Y? It's not really sure what it wants from me. Okay. So if I want those two lines to be perpendicular, what do I want this angle to be right here?
90.
So is there an equation I can write to find y?
90 equals 4y minus 2.
Right. 4y minus 2 equals 90. Anyone get an answer for y?
23.
I have 23. How are we gonna find x?
2x plus 5x plus 6 equals 90.
Right. Together, those two angles make 90 degrees. Is it 12? Someone should check my work. I think it's 12.
It's
Yeah.
Okay. And we just have, I think, 5 true or false on the next page. Just looking at those relationships and seeing if we can identify them in a big picture. So true or false, here we go. DBC and ABG. Are those two angles complementary? You guys remember what complementary means? So close, the other one.
Oh,
90. So do those two angles add to 90? They could, but do we know? No. We don't have enough information, so you're going to write false. ABD and angle CBD are a linear pair. What do you guys think? Do they form a straight line? They do. They do. BF and BG are perpendicular.
True.
Why is it true?
Because they're both 90 degrees, they add up to 90.
Yep, we have that little box there. Yep. ABF and angle FBC are supplementary.
True.
Yep, because they make a linear pair. That's true. And our last one here, ABG and GBD are adjacent angles. What does adjacent mean?
Yeah, there's a
False.
vertex inside.
Yeah, do they share a side and a vertex?
Yes.
BG. BG, look, it's in both of them. BG. BG. True. True. We'll get better at these. It's a lot of new stuff. A lot of new words. Will you take out your planner for me?